Welcome once again to the computer vision zero to production. So now will be before we move to training, right? I think it's best we look into the YOLO architecture overview, right? So let's okay, let's look into how the YOLO architecture works. So let's say this is the main image, for example, an image. Let's take a rectangle. Let me increase this in size. Okay, so let's duplicate this. Duplicate. Okay, let's reduce this in size. Okay, reduce this in size also. Reduce this in size. Duplicate. Let's have this. So let's get an arrow, get another one, get another one, get a new arrow, get the new one. So let's call this the early stages of the convolutional neural network. Early stages. And let's call this, let's say this goes to, this analyzes the colors. And let's say this, right, is later, or let's say late in this later stages, which like explores the high level features. And let's say we have a backbone here. So the backbone is a pre-trained network. It already knows how to extract features from images because it was trained on ImageNet with millions of images. This is transfer learning happening inside YOLO. When you train on our full data set, you are fine-tuning the backbone of it, not starting from random, as opposed to, like, let's say we want to use like a mobile net or efficient net model weight. So, which is the backbone. So we then have to look into like the next system in YOLO. So let's say we have a new rectangle box here. Let's say we duplicate this, duplicate, and duplicate one more time. So this would be smaller. This would also be smaller. Let's say this is here. So how this translate now is this is a multi-scale output, or this multi-scale output is why YOLO detects both small kiwi in the corner and large banana, filling half the frame in the same image. Small objects are detected in like 80x80 feature map where spatial resolution is preserved. Large objects are detected in 20x20 map where the receptive field is wide enough for the whole object. So let's label this well. So let's say this I did not complete this labeling. So this, let's say this is our 640 by 640 image. Duplicate this, duplicate once more, duplicate once more. Okay, so by the time this gets here, by the time this gets here, let's say it is already 320 by 320. By the time this gets here, let's say it is already 160 by 160. By the time it gets here, let's say it is already 80 by 80. By the time this gets here, let's say it is already 40 by 40. And let's say by the time it gets here, it's already 20 by 20. So for this, right, in the neck feature pyramid, let's update this. Let's say this is our 80 by 80. Let me just copy this, duplicate. So let's have this here, duplicate, and once more. So all these are resizing. This is, let's say, 40, and this is like 20. Okay, so let's have an arrow that comes from here to here. We also have one that comes and do this. Let's get one more that comes from here to here also. Okay, so this backbone diagram, it shows the image shrinking spatially while getting deeper in channels as it passes through the convolutional layers, like I said. And the neck diagram, which is here, shows the 3-scale feature maps merging through upsampling from here to build outputs that capture both fine detail and large-scale context. So we need to now discuss how the dataset connects to the model, which is what we have here. So according to your documentation, right, you have to define the parts where your data actually resides. Then these are the sub parts where you have your train, val, and test. So the package, your Felch's package is built in a way to automatically identify that your labels are also in this train, validation, and test. And we have this number of classes as 6 to tell the YOLO that okay, we have 6 classes in our data set, and we then have the names of those classes. These are important nuances for you to not have training errors while you are running your YOLO model training. So we'll be moving to training our model on Google Colab. The reason why we want to move to Google Colab in our next video is, like we said in our earlier videos, is to give us access to the free GPU for us to train our model on. See you in the next video.